Sir, Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. Today we will discuss different types of machine learning techniques. Learning outcome. At the end of this session, students will be able to describe different types of machine learning techniques. Learning outcome. So first we will see different types of machine learning as usual, and the next we are going to study what are the steps to solve a machine learning problem. As we see here, there are three types of machine learning algorithms which are very popular. One is supervised learning, second is unsupervised learning, and third is reinforcement learning. So we will see one by one what is supervised, what is unsupervised, and what is reinforcement learning. So supervised learning, what is given is data that is called training data and the desired outputs with labels. Okay, so outputs are also given with labels and training data is also there. And the machine learns through examples of which we know the desired output. That is, for example, is this a cat or a dog? Are these emails spam or not? So these are the examples of supervised learning. For example, cats are identified by the machine, or dog is also identified by the machine, or even email spam, whether email arrived is a spam email or it is a non-spam email, the algorithm can identify. So it predicts the market value of a houses given the square meters of size of the house, the number of rooms present in the house, and the neighborhood stressor. So these are some features used to predict the house price based on its size, number of rooms, and the neighborhood or the locality, we can say. So whenever there is a training data is present with the desired outputs with labels, then it is called supervised learning. Here we see the supervised learning can be again further categorized into two categories. That is, classification is one of the method of predicting or classifying the output. So here in classification, the output is a discrete variable, that is, as we saw earlier, whether it particular animal belongs is a cat or a dog, one of these two. So to the right side, if you look at, we see that say for example this blue dots represents the dog and this orange represents cat. So this is a demarcation line between these two categories, and we can divide these two categories into two. So this type of learning of a data is called supervised learning, because we know this orange means it is a cat and blue means it is a dog. So the machine can categorize it. And another is regression, where the output is continuous. It is here it is a discrete, okay, but here it is a continuous. That is, for example, the price of a stock or temperature of a room can be a continuous value, because temperature changes as day that means sun rises. So this way the price of a stock, for example, can be predicted in future if the current pattern is like this. So the supervised learning can be classified into two categories, that is classification and regression. But in unsupervised learning, see here, given means the input is training data but without desired output. Earlier in supervised learning, desired output was there with labels, but here desired output is not given. So there is no desired output in the unsupervised learning, and the machine learns something from the data itself. Okay, so the machine learns something from the data itself. For example, I have photos and I want to put them in 20 groups. Okay, so we don't know how many photos are there. Okay, and how many groups of photos are there. So machine itself learns from the given photos, and it can categorize into 20 groups on its own. So machine is not told to do 20 categories. Then say for example, I want to find anomalies in the credit card usage patterns of my customers. So what anomalies are there, it is not given to the machine learning algorithm. Only the machine is asked to find out the anomalies, and the machine itself learns and find out the anomalies, or we can say abnormalities, or we can say unauthorized transactions on the credit card. So if you look at the unsupervised learning, useful for learning structure in the data, that is called clustering, or we can say hidden correlations, to study the hidden correlations, and also it is used for reducing the dimensionality. So here if you look at the left side, this is what the input, okay, and the machine learning algorithm has itself identified this input into 3 different categories, that is red, blue and green, and it has categorized into 3 categories. Okay, so based on the earlier discussion, there is a question, that is differentiate between classification and regression. You pause the video and answer the question. So before going to the next, as we know, classification is what we can say discrete output. Classification gives the discrete output, whereas regression gives the continuous output. That is what the difference between classification and regression. The third is reinforcement learning, where the reward from sequence of actions, either reward or punishment, can be occurred. So if you look at here this diagram, this is what the environment and this is what the agent. So agent does some action, AI, and based on the action, the environment may give some reward or punishment in the form of this feedback to the agent back, and this moves this environment into next state. That means agent is moved to the next state. So this is what a closed loop, and based on this reward or punishment and the state, the agent does next action, and based on the next action, again the environment reacts to it, giving reward and next state. So this way agent and environment interact at discrete time steps called 0, 1, 2 up to k. So t is the variable. Agent observes state at step t, that is Si belongs to the set S, produces action at step t, okay, At belongs to A of St, gets resulting reward, that is R of t plus 1 belongs to set of rewards or punishments, and goes to the next state, that is called S of t plus 1. So this is again shown here in state diagram form. So this is the St of St plus 1, St plus 2, St plus 3, and these are the states, and here the output is that means reward is after some reward or punishment, it goes to the next state. So this is a reward t plus 1, this is a reward t plus 2, this is a reward t plus 3, and there is a action at every state. So because of this action, it goes to the next state. So this is what reinforcement learning. Now the last we study the steps to solve a machine learning problems. So importantly, this diagram gives us the idea of machine learning problem, the problem, real life problem, how it is solved using machine learning technique. So the first step is data gathering. So we collect data from various sources, and then we require to clean the data to have homogeneous data, and that is called data pre-processing. Then we have, as we studied earlier, feature engineering. That means you adjust the features, or we can say outliers, imputation, scaling. These techniques you use to make your data more useful. So apply feature engineering to the data to make the data more useful, and then give this data, clean data, useful data to the algorithm for training, and select the right machine learning model for the training and train the model using this data. And finally, this is used for making prediction, and naturally we can evaluate the performance of the model as well. So these are the 5 steps involved in machine learning technique, which can be applied to any given problem. So these are the again in short, everything is described here. So there are 2 phases in machine learning algorithm. One is training phase and next one is a prediction phase. So in training phase, the labels are given to the machine learning model, and even data or samples are given. From these samples, features are extracted, and these features are given to this model. Okay, so labels are there, outputs are there, desired outputs are there, features are there, and this machine learning model is trained. And after it is trained, the new input is given, whose features are extracted, and these features are given to this trained classifier, and this can now predict the output, that is called label. References: I used machine learning book by Tom Michel, by McGraw-Hill publication, and another is a Foundations of Machine Learning by Meher Mori, MIT Press. Thank you very much.